and we're doing real fast because a lot of people were absent. And a lot of people were sleeping, and so it's basically absent. So, here we go, section 3.4. Your goal tomorrow is to finish this homework, but today you're going to see extra examples because you're going to get stuck in homework, long story short. If you haven't already, you're going to get stuck. So I want to try and help you with the examples today. Cool? All right, so, ready? For those of you that are like, I go home, I try the homework, and I get stuck.
I don't think it's that.
Oh no, she's in my period one, but she was absent today, at least for my class.
All right.
Sorry.
Bye.
Bye. We are in section 3.4, where all the puzzles are. Well, 3.5 has them too, but different ones. Different. It's just way different. It's going to feel more like a science lesson or like a lab than anything else. Section 3.4 is the culmination of all the things we've been doing in 3.1, 3.2, 3.3. For those of you guys absent yesterday, we basically said, hey, remember this guy? We're going to use him. Remember that guy? We're going to use him. And then, wait a minute, wasn't there a time, for those of you that were awake and paying attention, didn't I pull up on the webcam the back of the book for section 3.4? Why did we look at the odd answers? They like natural law. From their further experience in the science and the maths, that's how the British people say it. But anyway, in the science and in the maths, they're like, LN is the most important guy. Remember, John took out his AirPods and I said, hey, LN. He's like, yeah, it's important. Done. Okay, LN, it's important. And there's people way beyond him who are making these answer keys. So what's weird about that? We did an example yesterday. We're going to come back to that, yeah? We did an example yesterday where we could not make the bases match. This one we could, and whenever we make them match and we solve, that's called the one-to-one property. Some of them are easy like that. But then we got to this one, and it was like, okay, make it match or undo. This one, make it match. This one, undo, because we got to 14, and is 14 a perfect power of 2? No, it's 2 and 7. Okay, so 14 is not a perfect power of 2. We cannot make it match. We undo, and we said, what would you naturally undo? Hopefully using the inverse property, 2 to the power of with. And most people would say what? Log base 2. Log base 2 of 2 to the power of it undoes. It's gone. It's nice. It's easy. It's x. Haha, done. But then I brought up the point, what if the back of the book has this answer? And you had this answer. Are you wrong? No. And what would happen if you plugged this decimal, if you plug this in your calculator, what would happen with this decimal and this decimal? Which is why in your homework, have you seen it? It says solve and then approximate to 3 decimal places. Why? Yours might look different but still be right. If the decimals don't match, what are you? Wrong. Right? If the decimals don't match, you're wrong. The decimals do match, you're right. So why on earth did I start harping on you guys not just knowing that these are the same answer, but actually, Nathaniel, I see that, hold on. But actually helping you get there by yourself in your solving. Why would you want to go straight to their answer instead of just making the decimals match? It's easier if you just land on the right answer for checking, number 1, and number 2 on the test. Do you remember what I mentioned about all the multiple choice questions where it's solving for x? Are the A through E going to have decimals? So if they don't have decimals, that whole decimal matching strategy, it's going to take you time. Because you're going to have to plug in every single A through E if it doesn't match yours to see which one matches yours. So are the decimals matching okay for homework to know that you're right? Yes. And for the evens, I want you all getting decimals because if it looks differently when we grade tomorrow, I want you to be able to look at the decimal in the answer key and be like, okay, I was right, I just didn't land where they landed. This and this are the exact same. We could do it with a change of base formula, but it's a lot nicer for some of us instead of having to remember this change of base formula like awkward, bleh. And some of them are harder than this, like the one where you were just trying to solve for x. It's easier if you land where they land. And to land where they land, where you would naturally say, log base 2 undoes. You're not wrong. But use an ln instead. It's the preferred logarithm in the scientific mathematical community. For the most part. Use ln instead. And guys, does ln of 2 cross out like log base 2 of 2? No. What property are we using instead? And Nikki, this was yours that you were showing on yesterday. Power bring the x down. This is now a constant that we divide by. We landed there and didn't even remember the change of base form. Multiple ways, landing where they land. Okay? Now, I just gave you, well, no. At the end of yesterday, I was like, let's give you a challenge. And then I was like, okay, now what? And those of you that were like, I like the log base 2 thing, you were like, because would log base 2 have helped on both sides? I have 2 different exponential expressions. I need to solve for x using both of them, and here's the dilemma, they're not the same base. So whether I use log base 2 or whether I use log base 3, it wasn't going to work out perfectly anyway, so I scratched the whole deal and said, wait a minute, what's the preferred log? Okay. And then power property says, bring both of those down, but now we're stuck. Okay, we're all caught up to the beginning of class. And I'm so sorry, I've lost my smartboard marker. It's really annoying me. I'm using it so fast. Okay. Algebra throws me off. Here we go. Some of you, algebra throws you off too. Anyway. Exponent properties struggle, right? Little things that we learned forever ago, but we didn't learn them super solid, and they come back to bite us in the butt. Has anybody figured out how to get exponents? Someone raise a hand and be like, well, I tried this. Give me something. We have to somehow rewrite this, because right now I can't just like, yeah, that's equal. What'd you do? Something. Yeah.
The L and 2.
The other side? Okay. I guess we could. Let's see if it helps. X equals. I'm going to write it a little bit weird, if that's okay with you guys. It's still just as legal. I'm not trying to trick you. I'm not doing illegal things. These are technically just coefficients, so I can go ahead and pull it off to the side and say, okay, it would distribute, I would divide everything, I would multiply everything. I'm not sure that's what I would have done, but it's not awful. What else? Okay. You're right. It's really quiet when he's up here. I shouldn't do that. But good. He's like, you can divide the x plus 1. Does that change what it looks like? Yes. Is that what I'm asking you to do? Is change it up? Yes. But is dividing changing it up in a good way? No. And here's the reason why. You're getting this more stuck in a denominator rather than we want to somehow get like literally, like x terms on one side. Adding and subtracting as simple as possible. Not multiplication, not division. We want addition and subtraction of x terms on one side. So if we have all the x terms, we can pull out that x and ooh, he's by himself. So I don't want to go dividing because that makes it more complicated. But I also don't like this multiplication because he's stuck as well. What would set him free? To add or subtract, what would set him free? Come on, I know you don't see it, but tell me something. I can't subtract right now because he's stuck in multiplication, but you're right, that's what I want to do. I want to subtract. What sets him free to be subtracted? Multiplication. The only way I can add or subtract is if all the multiplication is gone, all the division is gone. So therefore, I know you don't like it, and that's what's trapping your brain. Like you're in this little like mental prison that you've made for yourself, being like, I don't like it if it gets hard. Or if I don't see the path clearly, you gotta keep going. Ooh, so when we multiply, what happens? I don't know. It looks gross. Okay, so write down the grossness. You know how to distribute. I know you don't like it. It's like me telling algebra kids, if it's, oh, ready? This is where their brains get stuck. Their brains get stuck in something like this. They freak out. I'm like, seriously? Come on, like, right? What would it be? You guys have learned fractions aren't awful. X would equal what? Okay, but you back in Algebra 1, you hated it too. And I know some of you because I had you back then in Algebra 1. You hated it. But is it a big deal to say x equals -5 halves? No. It's fine. It's perfect. It's great. Don't go to 2.5 there. I mean negative. Okay, ready? Do that here. Don't be scared. It's gross. I know, but write it. Whatever. For some scientific people, whatever, we use LNs all the time. Okay. Hold on, we have this. What was the goal? To be able to move x and subtract, add or subtract. Can I subtract it now? Yes. And why does that make all the difference? Not making it look nice. But we looked at the answers in the back of the book yesterday. There were some nasty looking answers. What can I do as soon as I have addition or subtraction of x terms all on one side? I get all this algebra 1 stuff today. Pull out x. I'm not making fun of you. I'm just trying to show you that it's possible. Get out of that mental prison and be like, oh, sure. There's a GCF, so factor. What's your final answer? It's not about making it look nice. It's about getting x alone. Remember, if you're in a lab and you're supposed to be finding, well, I know it doesn't make quite as much sense. We haven't gotten to section 3.5 yet, but if you're solving practical problems, exponential growth and decay, radioactive decay, population growth, bacterial growth, virus growth, infectious spread, if you're doing all these word problems that use exponential functions or logarithmic functions, there are going to be times where it's like, okay, so in this situation, if x is, how fast is it spreading? And you have to plug and chug it. Or you have to get x alone. Can you do the math? It's a lot of algebra, even though there's a little bit of logs, it's a lot of algebra with scary stuff. But come on, distributing, subtracting, factoring, that's algebra, right? My final answer, however gross, is something you can totally throw into your calculator. Right? Maybe the back of the book would have a decimal because they gave up a while ago and they just went to decimals. Went to their little scientific calculators because remember in college they don't really let you use graphing calculators, rarely ever. Just a thing. In math classes at least. Science classes maybe they'll let you use it. But plug and chug this. You could plug and chug it to a scientific calculator and get your decimal approximation for x, but this is the proper form. Which you could technically make a log base 2 of 3 and a log base 2 of 3, but ew, gross, just use LNs. That's what they're going to do. Hang in there. I think we're going to have extra time after exams.
No, I mean like the
directions?
Yeah.
Yeah, go ahead.
So it's saying solve, but then there's like a square root and then the log.
It's saying solve it, and once you finish solving it,
Yeah. So
we're giving you decimal approximations to plug in for these square root pieces.
So I can use my calculator.
Yeah. Okay. That was a really hard one. Can we go to like a more basic one? Because if you guys remember yesterday, I found this example like from the end of notes, and I was proving the point that sometimes, even though sometimes using ln is optional, log base 2 of 14 was appropriate. It was accurate. It's just not quite as well known or commonly used. Sometimes ln is necessary. There was no way to use log 2 in this one and have it be all peachy. There was no way to use log base 3 and have it be perfect. We had to get an ln in there. Let's go play with some easier ones. You guys ready to get easy for a sec? Here we go. What would you do to solve for this guy? E? I love it. Because E and ln are inverses, right? What, are you going to be scared of E squared or say, nope, that's fine. That's a perfectly acceptable answer.
Do you want us to like put in E squared in our calculator?
Well, but in this one, do you really think there are... Now, the directions are going to say approximate to 3 decimal places because they want you to make decimals match. If I were you, E squared, I mean, that was a super basic move. That's exactly what the book's going to have. When you start putting in logs and you start doing weird bases, that's when I'm having you guys on the evens, because you can't go check CalChat at the back of the book. On the evens, get all decimals for every single answer, because tomorrow, if something goes wrong, I want you to know whether your answer is right, just different. Does that make sense? So when you grade, I want you to be grading decimals tomorrow on the evens, and then you can look at the form and see if you made it match. But but on the odds, just go check it out. I bet they have these squared. Aiden, I see you, but it reminded me that I totally ignored the previous question. Give me 1 second. Sorry, bud. Give me 1 second. Sorry for ignoring you. I meant to get back to you. Aiden.
I guess more of it, please.
Okay. You remember, Nathaniel. Get my attention. How about letter B? Oh yeah, it's totally 1 to 1. It's the same, so I can ignore, but isn't there math that can be done also? 3 to the power of both sides? Either way, 1 to 1 ignore, or 3 to the power of it's gone. Okay. Mental math. Not saying you should do it on a test, but for right now, what do we get? Got it. You would solve it, right? Legally, algebra. Okay. Do you see their directions? Decimal places, yeah? Hey. Woo-hoo. All right, good. We just solved that one, right? Let's not do it again. It was bad enough the first time, right? Let's ignore him. But over here, what do we do? 24 or divide by 3?
Divide by 8.
24. Oh. 24 or divide by 8? 10 bucks. That's something else we saw yesterday, those of you guys that were gone. Don't put these guys together. 8 to the 1, 3 to the 6 minus x. Those bases do not match. But I can isolate. I'm having issues. I can isolate my exponential piece. As soon as I isolate it, oh, life is good because I can undo with. Okay, you have to choose. There are 2 different paths. The one less traveled or the one more traveled. The one that seems easier right now but harder for matching, or the one that's going to match up with what they have? What am I asking? Which log are you going to use? If you like to match the back, you're going to go with the preferred log. Some of you are like, log base freak, cancel. I know. If you're going to make it match, just use ln. And what does ln let you do?
Power.
Power property. One of them, right? Power property. 6 minus x. You're like, it's so much harder, but it'll match. I gotta get to him. Divide. 6 minus x is equal to ln of 5 minus ln of 3, or divided. Subtract 6. Dangerous to count. I'm saying it's dangerous because some of you are going to subtract the 6 and be done and forget the negative. It might be a little safer to add the x and subtract a logarithmic expression, but eventually we're going to end up with 6 minus ln of 5 over ln of 3. For those of you guys that did it the other way, you would have gotten x equals 6 minus log base 3 of 5. They're both right. Their decimal approximations will be the exact same thing. This is the preferred answer choice on the test, slash back to the book answer. Okay? Both right. Both right. That's the strategy then. Could you plug every single one in and get decimals and make it match yours? Hopefully. It's going to take time, right? Every A, B, C, D, E. Yeah. Okay, we can skip the nasty ones. We already did it. Nice. Again, right? I'm going to be super nice to you right now. If I were you, I would write right now. Because some of you don't listen to me right before the test. Maybe you'll listen to me during the section. It's going to be the bonus on the test. Which means, and some of you totally ignore this craziness. Yeah, you want? But that gives some of you extra motivation to actually be like, oh, go team, show me how to do it.
This is the same type as
Similar type. Similar type, I know you were. Similar type. Okay. If some of you understood the math involved in this problem, you can all see why it looks nasty, right? Some of you are thinking, ln does not distribute. Nope. Taking ln on both sides, well, ln of 0 doesn't exist, but anyway. If you understood the math, maybe you could understand how, if you understood the math, I think a few of you have the mental math capacity to be able to understand how. The final answer to this
X minus
is going to be ln of 2 and ln of 3. If you understood the math, I think some of you have the mental math capacity to get there. Maybe, just a few of you might not be able to get all the way there, but you would be able to get all the way to here. 2 and 3, how did she get 2? ln of 2, ln of 3. Maybe you couldn't have gotten there, but maybe you could have gotten here. Maybe you would have understood this is really just, that's the question. It's really just a quadratic equation. Whoop! No, it's not. E to the 2x's. Oh, I know. It's a struggle. It's a little hard. I got you. Who is this e to the 2x? Wait, you multiply powers when you raise a power to a power. Because a power to a power, x times 2, ew, gross. 2 times x, better. Technically, this little guy at the very beginning of this expression, I could rewrite 2x as x times 2, which would be e to the x to the second power, because a power to a power you multiply. It's splitting up with exponent rules backwards, which is weird. But this whole guy is, whenever you see him, I think you're going to see maybe 1 or 2 in homework, and then he's going to be a bonus on the test, and that's it. He's a quadratic equation that just needs a little bit of factoring, but it's not x equals 2 and x equals 3. It's who the u was. E to the x equals 2 and e to the x equals 3, because this is a quadratic equal to 0. If I equals to 0, and if I have factors, I can teach in Algebra 1, like Moses in the Red Sea, split, which chapel yesterday was quite conducive to that. Split. And set each one equal to 0. Got him, but I'm not done yet until I take ln. It's the hidden quadratic. It's a hidden quadratic. Not x squared, but e to the x squared. Okay, but long story short, is it on homework? Yeah. Is it on the test? As a bonus. It's up to you whether you need to go the extra mile and figure it out. But does it look crazy hard when I just say it's a factor? Hopefully not. Hopefully not. And just for some of you, sorry, I did my guess and check method. What multiplies to be 6 and adds to -5. Hopefully the -2, -3 wasn't the hard part. Hopefully the ln got it to be a little weird. Huh. Out of this entire section, I think this whole 2 to the 3 to the, with the weird x's, how do we get them alone, and this quadratic is typically the ones that the kids hate the most. Ready, set, let's see if you can, is this the hardest problem of the entire section? It's at the end. Go! Is this the hardest problem of the entire section? It's at the end. I started hard, I'm ending easy today. It's so backwards. What's going on? Take your time. 2 plus 3 ln of x equals 12. Use your algebra. Remember, dividing by ln, means that. Undo ln. Don't undo ln until you get him alone. The air just turned off. Some of us are very thankful. Hang in there. It's not going to get colder. It might even get warmer. is if you do it right, that whole 3 decimals, like Nathan was asking, I mean, this isn't even, so technically I would want you to get the decimals just in case the book wrote it weird. But as long as you're using the lens, you should be fine. You shouldn't even have to go do that weird calculator step. When you go to match the odds at the back, it should match up perfectly. So it'll save you time. Okay. I need to make sure we started it right. If you started with an E, you are totally wrong. Because your operation order is illegal. If I throw an E in right now, you're going to have to remember so many Algebra 1 exponent rules to legally go about what to do next. If you threw an E in, you've made your life so much harder, and I can almost guarantee that you're getting it wrong. What would have been a wiser step to do? Get rid of him. Well, here's the struggle. No. It happens. We make algebra mistakes. If you divided the 3 first, you did it illegally, I can almost guarantee. Because if you divide by 3, let me go back real quick. Some of you, I know, you're making algebra mistakes. I wish I had taught all of you algebra. Not that makes you perfect. It doesn't at all. But at least I would know why you're making these mistakes. It happens every year, but for some reason this year it's a little bit more of a struggle. Is this legal to do? No. Because I have a plus. This division would have to distribute. You just killed a kitten. You're like, no. PEMDAS, solving algebra, says go backwards with PEMDAS. So addition, subtraction, then multiplication, division, then powers. Depending on how it's written, that's the hard part. But check it. If you subtract the 2, that's totally legal. I subtracted the 2, I'm good. 10. Now, what do I need to do? If you do the E, I can almost guarantee you're going to go about it illegally because you cannot, this is killing a kitten also. You're bypassing the 3, which would have had to come up to be a power. If you're doing the E right there, I can almost guarantee you made an illegal mistake. You didn't raise it up as a power. So, not E yet. What's next? Divide by 3. Now some of you, you're avoiding this fraction as much as possible. You have to get over your fears. Go about the legal math. 10 over 3, it's a thing. As soon as I have ln of x is equal to 10 over 3, what is completely, utterly, necessarily legal? E. No, it's fine. What does x equal? E to the 10 over 3, or if you want to be super snazzy, it would be the cubed root of e to the 10th, but I'm totally good with it.
If we buy it the other way, can we get extra coins?
You never know. I gave bonuses that one test for writing the F inverse. Speaking of tests, one person, every single group, go back and get correction papers. Let's go. You wanted them yesterday. You guys didn't even mention it today. That's weird. Wait, why is she just randomly running to test corrections?
Yeah, our test is next Tuesday.
Because we're almost done. The rest of you guys, waiting in your seats, play with this one. It's the last example of section 3.4.
Oh yeah, it's hard. What about this CD? I really don't understand. How many seconds do you have to do?
Any of the ones that are legal? Hey guys, last example. For section 3.4. I just showed you cannot do an e to the ln until you have it completely, listen to my words, condensed and isolated. You cannot use the inverse property to get rid of a log or an exponential until you have it completely condensed in one spot, isolated. Why am I using the word condensed? Solve. I'll pass that test. All right. Your name? I'm going to 80. Spencer.
I don't care.
Dylan, you're doing a lot of things. They do one thing. Griffin, come on down. Wait, come on down. Randy, come on down. Vanessa, come on down.
I know what to do. I'm really happy.
Alyssa, Nathaniel, Brittany, Diego, Jack, Ivy, Laura, Emma, Lucas,
I'm so scared.
I'm glad you guys know.
Alright.
Oh, you took your plate. In a different spot. Yeah, you were the makeup one. I didn't have here, right? Okay, guys, listen real quick. Test corrections on this test will give you 1/3 points back. I'm supposed to be weaning you off of the extra points because you're learning how to study for tests. But listen, we have a test in chapter 3 next Tuesday. So technically, what is your priority? Studying for the chapter 3 test and doing well on that one. So these corrections will not be due until next Wednesday, Thursday, something like that, okay? I'll give you like a week, put a little bit more, get to the chapter 3 test. But some of you are like, I'm rocking chapter 3. Okay, play with corrections if you want. You can also just put it safely away. Those of you that keep losing things, safely away. Safely away. You can always go back and grab extra correction papers if you need. But I have people in the section 3.4 homework that are getting stuck because it gets hard. So can I at least with you solve through one more hard example before we leave today? I don't think it's as bad as the 2 to the 3 to the, but it's not as basic as the factoring a quadratic. That looked weird, but it was basic math. When I said the word condensed, come on, someone thought, oh, I should use what property? Quotient property to get the separate logs.
Thank you.
The separate logs together. Because wait, we want to get rid of the logarithm to get the x, right? If I can get the separate logs legally together, and there's nothing else, no subtraction, no division on the outside. Lucas, Brandon, focus. What can I now do to get rid of the log base 4? It's condensed, it's isolated, I can't undo using a power. Or I do to one side, I do to the other side. Are there a few of you that would possibly misread this? So if it was a 25 to the 1/2, you would be lost, when you really shouldn't, because 1/2 just means square root. Over here, ha ha! But now, some of you are stuck with the algebra. But you shouldn't be. Because I said, remember, we want to simplify as much as possible. Division is harder than multiplication. Multiplication is harder than addition and subtraction. We want to get to addition and subtraction. So what's the only way to keep going? get rid of division, then get rid of multiplication, then try to get all the x's to one side. So, Emma, you were saying it, right?
Yeah.
Getting rid of my division. Distribute. Solve. Add the 1, subtract the x, I end up with x is equal to 1.
I have a question.
Yes.
Why is it 2x minus 1 with 2x minus 2?
Did I fail at subtracting? No, I didn't fail at subtracting. I fail at
Wait,
Gracias. I don't know. Feel maybe my distribution. Subtract the 2x. Negative x equals negative 2. Therefore, x is equal to 2. Oh, wait. Isn't that good? Pause. 4 classes over at 20 seconds. Can I tell you one thing that's going to show up in homework? Ready? I'm about to take my answer that my math was like, of course it's your answer. One of your vocab is going to be the word extraneous. Extraneous is a title of a solution that doesn't work. No, the math always gives us the right solution. Pause. Ready? Watch. Watch. Are logarithms allowed to have positive numbers? Yes. 2 is a positive. Woo! 2 minus 1 is a positive. Woo! He's legal. I'll keep him. If it had been a negative, he's illegal. I lose him. He's extraneous. You'll see it in homework. Bye, guys. Good job. Go back with your puzzle. Come back tomorrow with what went wrong. Next Wednesday or Thursday after the family free.
No, that's what they call it. Kayla had